Hi, my name is Jers. This is my grad presentation project as part of the grad assignment for GIS 516. And this presentation is based on the article Scavenging Affects the Persistence of Avian Carcasses Resulting from Window Collisions in an Urban Landscape. And so the purpose of this study was focusing on the issue of bird strikes against window collisions. This is a known issue, especially in many urban landscapes and cities, where large and reflective windows can make a window look like an opening or an area of opening for birds, and so birds hit the windows and usually they're fatal strikes. And this is something that is reported. Researchers go out, they count the number of bird strikes, and they report that. And this study looks at the possibility of bias that could be introduced when this is happening. Specifically with scavengers, such as raccoons and opossums, that might go out and move or eat these carcasses before reporters can get to the area to count the bird strike victims. And this would interfere with the data. And so because of this, the study looks at what conditions affect the behavior and presence of scavengers, and how does that affect how these carcasses and when these carcasses are moved, in order to understand this interaction and to then minimize bias in the future, specifically spatiotemporal variation in scavenger distribution and activity. And the study looked at what those factors would be that would affect scavengers, such as raccoons. That would be local habitat structure, building window area, and seasonality, the time of the year. And they predicted that carcasses, the bird carcasses, would persist, meaning they would be unmoved by scavengers the longest during the winter at buildings that had few windows and where there was low forest cover. They also provided for future studies a mean survival time of persistence to inform what type of sampling intervals researchers in the future could adopt if they were to repeat studies involving reporting bird strikes. And so the study area was 2 cities, Rock Island and Moline in Illinois. And overall, they looked at 20 buildings, 15 study points plus 5 large buildings. And we'll get to why there was a distinction there later. These 15 study points were in 4 land cover types: high density, which is any areas that have high structures and buildings; low medium density, which is 50% structures; urban open space, such as golf courses and parks; and forest land or floodplain forest, which is mostly forest with maybe a couple structures. And the researchers in the study, they used ArcGIS, specifically the stratified random sampling capabilities that ArcGIS provides. This was done to distribute these 15 study points equally in all of these areas. And so it was done equally and randomly. And this was to obtain a sample of buildings with enough variations in the local land cover. And they also were able to look at the habitat attributes around the building. This was digitized from a Bing Map high-resolution aerial photograph in 2010, and they were able to create a 50-meter buffer zone using this that provided the percentage of tree and vegetation canopy, the exposed habitat, the structures, and the pavement. The way they were able to obtain these carcass samples to be able to place them, they were salvaged from July 2007 to September 2010 in Augustana College in Rock Island, Illinois. And so this area had the same composition structure to the study area that's being shown here. The carcasses were frozen immediately, and then for this study they were thawed before being used. The statistical model they used included the covariates of season, habitat cover, and window area, and they used known fate models in a program MARC. And each day was split into 7 intervals to get a daily probability of carcasses persisting. A logit function was used that modeled the survival of the carcass as a linear function of those covariates. And the top model of a temporal variations effect on survival was then used to evaluate the effect of habitat factors on the other models. And they realized that there was a correlation between canopy cover and pavement cover, so they kept those covariates separate. And they also estimated mean survival times of carcasses at each buildings for future studies. The way they monitored these carcasses was using cameras, and the reason there was 5 buildings separate from the 15 study sites in that distinction was because some of the buildings, the owners did not give them permission, said they did not provide the permission needed to be able to use the building, that area, as a study site. And also there was some buildings that had risk for camera theft. And so it was, the usage was restricted to buildings in 3 of the 4 land cover types. And these cameras are motion activated, so as soon as they sense motion, 3 pictures were taken, and time, temperature, and the study building was attached to those pictures. The researchers also took some measures to make sure that each of the visits were unique. There were no repeat scavengers, or maybe like a raccoon that would go and then come back again. There were no non-scavenger species like songbirds, and they made sure to define what a scavenging event is. For example, does partial consumption of the carcass count as a scavenging event? And so the importance of ArcGIS here is the stratified random sampling that we mentioned, that it was used to select these 15 points to equally distribute them randomly among the land cover types. And so ArcGIS, it allows researchers to split a study into strata to generate random samples in each. And from their website, they have it described as strata can be adjusted based on prior knowledge of the phenomenon. For example, concentric circles can be made larger as the distance from a point source emission increases, providing some spatial structure to the sample. So ArcGIS was able to give these researchers the ability to distribute these points randomly and equally among the land cover types. And because of this, the variation, there was more variation that was able to be encompassed at these sites that would better emulate what actually happens in nature compared to when these strikes are being reported, or when these carcasses are being handled by scavengers. And so because of that, the idea of sampling bias, the reported numbers of carcasses being lower than what they actually are because of scavengers, can be avoided. And also ArcGIS allows researchers to process this map data and analyze it in ways that other software can't. For example, they also have a create random points tool that sort of works the same way the stratified random sampling. And so because the persistence of a carcass is explained as a function of landscape level processes, and because ArcGIS allows researchers to encompass this variation, they're able to see what local factors affect scavenger behavior that would then affect the persistence of a carcass. This is the spatiotemporal variation that ArcGIS is able to begin and to provide. And so the sample sites reflect the variety. It encompasses these interactions between the scavengers, their own behaviors, the habitats, and the survival of these carcasses, or the persistence of these carcasses. And it allows this bias to be addressed by minimizing the scavenger bias. And so in the results, 20 carcasses were monitored, and the number carcasses removed by scavengers was also reported. They found that raccoons scavenged the most compared to all the other scavengers, and they also were able to measure carcass sign. Carcass sign is usually what's left behind after the carcass is moved, such as feathers or soft tissue. And they looked at the presence, the amount, and even the composition of what was left behind. And the supported model they used included season, canopy cover, and window area as covariates. And they also had a secondary competing model that included pavement cover, season, window, and window area. And they split the results sort of into winter and non-winter. And in general, in the winter is more difficult and less appealing for scavengers to approach these buildings to look for these carcasses. Instead, they might choose more natural forested foraging areas. And so what they found was, as canopy cover increased, there was a decrease in survival time. So in other words, if the more tree cover, vegetation cover there was, the less of a chance, the less time the carcass persisted there, and that allowed the ability, that increased the chances for scavengers to take these carcasses, and that was more pronounced in non-winter seasons. And the more pavement cover, the more impervious surfaces there were, the increase in survival time. So usually pavement cover, sidewalks, roads, they're less appealing to scavengers because they might associate it with danger or a place where there might not be as much of a chance of food to forage for. That was also more pronounced in non-winter. And as window area increased, there was also a decrease in survival time. So the more windows there were, the larger the area there were, the larger the chance of birds thinking it's an open space, hitting it and falling to the ground. And essentially, scavengers might over time change their behavior to associate these types of buildings with more carcasses at the base of the building to forage for. And so increasing window area decreases the persistence of these carcasses at these places. And that was also more pronounced in non-winter. And this figure here shows exactly what I had just mentioned, the winter, non-winter, and canopy cover, pavement, and window area factors and how they were changed. And so in the results and future, they also considered some other factors such as distance from the building to the preferred habitat for a scavenger affecting the survival time of the carcass. And they also, like I mentioned, looked at scavengers being capable of learning a location and timing of food sources. And so future studies, for future studies to provide the option to reduce scavenging bias, the researchers suggested that for the future, you should maintain short time intervals between searching for carcasses. And that'll depend on estimating how many days the future researcher would think a carcass should persist at a site, which is based on the persistence times associated with that site. And that can be found using predicted daily survival probabilities and other a priori methods as well. Another alternative is at sites that have low persistence, where carcasses are known to be removed quickly, constant searching or constant intervals might be able to prevent the bias or lower the bias that would come with that. And it can also allow for detecting any carcass sign, any feathers or anything like that that left. And so for the future, this study highlights the influence of habitat and conditions on scavenger behavior. And ultimately, because scavengers can affect the reporting of bird strikes because they remove these carcasses or they eat these carcasses, understanding what factors influence scavenger behavior to then understand how they move or eat these carcasses is important in the reporting of bird strikes in a whole. And this is an important issue because 1 billion bird fatalities happen annually in the US and Canada, and any results that should be higher than they already are misreported results, and depending on the policies of the area that this happens at, it may not warrant prevention from the officials or whoever decides that something should be done about these windows that are causing these fatalities. And also, it can also distort public perception if they think that people are purposely misreporting these results. And especially in a time where the climate crisis is so prevalent and there's threats to species, especially endangered species of birds, this is something that cannot be afforded. And so this is my literature cited. Thank you.